The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to go on and take a look at covering Objective 1C, which has to do with integers. And I just want to say this, I've got up here on the left side of the screen, I have my textbook, and there are some definitions and boxes that I'm going to refer to. I'm probably not going to give you enough time to copy the whole thing down during this lesson, but if you need them, you can either go back and watch the YouTube video later, or the links that are in the WAMAP class have versions of this as well. But I just wanted them up here for reference, but there's a lot of stuff we're going to do today. So anyway, hang on for the ride. Here we go. All right. So first of all, I want to talk about distance. If we travel from Yakima to, let's say, Seattle, approximately how far would you say that is? And again, it depends on where you start in Yakima, where you start in Seattle, but there used to be a sign out on the freeway that said it was 144 miles. So I'm going to go with that. Okay, so let's say it's 144 miles from Yakima to Seattle. Then the question I have is this: how far would it be from Seattle to Yakima? Anybody? No takers? Okay, well, it would be 144 miles as well. The point being, distance is not measured with negative numbers. We wouldn't say, well, from Yakima to Seattle is 144 miles. Therefore, from Seattle to Yakima is negative 144 miles. I mean, maybe if you didn't feel good about going there, you might think it was negative, but distance is measured with positive units. The one exception to that, and it's kind of bizarre, is how far is it from right here to right here? And the answer would be 0 miles, right? But other than that, distance is measured with positive units. There's something called absolute value. And we see over on the left side of the screen, it says absolute value. The absolute value of a number is the distance from 0 to that number on the number line. An absolute value is never a negative amount. Two vertical bars, one on each side of a number, are used to indicate that we wish to find the absolute value of a number. For example, the absolute value of -3, or the way it's written there, this, expresses that we wish to find the absolute value of -3. Now, let's take a look at example 4 over here. It says, find the following absolute value. Well, if we have a number line, 0, -1, -2, -3, -4, and we want to know the absolute value of -4, what we're asking, let's change this to absolute value of -4. What we're asking is, what is the distance from -4 to 0? So the distance, or the absolute value, would be 4, a positive answer. Any questions about example 4 over here on the left? Okay, let's take a look at example 5. Find the absolute value of 5. Well, from 5 to 0 on the number line is 5 units. Oops. So the absolute value of 5 is 5. And then finally, what might be considered the trivial case, the absolute value of 0. How far is it from 0 to 0? It's 0 units. Any questions at this point about the idea of absolute value? All right. And we're going to go on to Let's see here. I want page. Oops, I've gone too far. Let's do this. 1, 7, oh. All right. Integers. Let's talk about integers. Integers are whole numbers and they're opposites. So they don't contain fractions or mixed numbers or decimals. They're like 0, 1, 2, 3, etc. to the right, -1, -2, -3, etc. to the left. So those are integers. The first operation we're going to look at is addition of integers. And again, I put the box here with a description. Don't panic if you don't get it all written down. You can refer back to it later, but I'm going to do a bunch of examples. All right, it says to add two integers, apply the following rules. Now, there are two cases. The first case, to add two integers with the same sign. So let's say we've got -4 plus -3. First of all, I want to note that I put parentheses around the -3 because it would be awkward to have those two symbols together. Deleting -4 doesn't need parentheses, though it isn't wrong. It doesn't need it because there's nothing written out here. So again, let's take a look at this problem. -4 plus -3. It says to add two integers with the same sign, add their absolute values and attach their common sign to the resulting sum. If the two integers are positive, then the final answer is positive. If the two numbers are negative, then the final answer is negative. Well, let's see. The absolute value of -4 would be 4. The absolute value of -3 would be 3. Adding them together, we'd get 7, but we attach the common sign of the original numbers, so it becomes a -7. So -4 plus -3 equals -7. Any question about that example? All right, let's take a look at another example. -6 plus -17. Here again, we're adding two numbers with the same signs. So we're going to add their absolute values. Oops. Which would be 23, but then we'll attach the common sign and we get -23. So adding two negative numbers, we get a negative answer. Any questions about that example? Let's say we have 7 plus 10. Here we're adding two numbers with the same sign. Now, what I'm going to take you through here, it may seem ridiculous, and perhaps it is, but just to show how it would fit with the description. The absolute value of 7 is 7. The absolute value of 10 is 10. 7 plus 10 is 17. We'd attach the common sign. These are both positive numbers, so 7 plus 10 equals 17. And I certainly don't expect you to do this problem going through all this, but my point is the description for item number 1 over here fits for adding two positives or adding two negative numbers. All right, so that's sort of the easier case of the two. Now let's take a look at the second example, or the second number over here. To add two integers with opposite signs, subtract the smaller absolute value from the larger absolute value. Then attach the sign of the number with the larger absolute value to the resulting difference in order to get the final answer. I need to tell you, the first time I read this long ago, I had a headache. It's like, what are they talking about? It just sounds awful. It's not that bad. We just have to get used to the idea. So first of all, let's take an example where we're adding two numbers with opposite signs. Okay, so we've got a +7 plus a -10. It says to add two integers with opposite signs, subtract the smaller absolute value from the larger absolute value. Well, let's see. The absolute value of 7 is 7. The absolute value of -10 is 10. So to subtract the smaller absolute value from the larger absolute value, we'd take 10 minus 7, which is 3. It says, then attach the sign of the number with the larger absolute value. Well, which of these two numbers had the largest absolute value? The negative one. So our final answer is negative. So it's a -3. So 7 plus -10 is -3. Now, that's using this formal description with absolute value and all of that. Let's look at this a different way. Same problem. Let's say that you go home today. Maybe you are home. I am. I guess everybody's at home right now. When the mail comes, you see that there are 2 letters. One of them is a rebate check for $7. The other one is a bill that says you owe $10. So you've got $7 to the good and $10 to the, well, we'll say to the bad. Okay. So the result of those 2 letters is what? Well, you owe more than you collected, so your answer is going to be negative. Does that make any sense? That's right. No one's going to respond today. It's just me by my lonesome. But anyway, so we get back to this idea of adding 2 numbers with different signs. Which one is more powerful? That's the one that dominates. Let's look at some more examples. -14 plus 3. So we've got the absolute value of -14 is 14. The absolute value of 3 is 3. 14 minus 3 is 11. But which one was more powerful? The negative. So the final answer is -11. All right. Any questions about that? Let's look at some examples. Hang on. Okay. So let's take a look at problem number 1 over here on the left. -9 plus -7. We're adding 2 numbers with the same sign. So we'd add their absolute values. The absolute value of -9 is 9. The absolute value of -7 is 7. 9 plus 7 is 16. But then we attach the common sign. Okay. So we get -16. Any questions about that?
No.
Yes? Question? No. Okay. Let's take a look at problem number 3. 6 plus -8. We're adding 2 numbers with opposite signs. The absolute value of 6 is 6. The absolute value of -8 is 8. Subtract the smaller absolute value from the larger absolute value, and we get a 2. But which of the original numbers had the largest absolute value? The negative, so it's -2. But again, you could think of it as I'm $6 to the good, then I'm down $8, so I'm down $2. In other words, you don't have to use this analysis, but for some people that works best. For others, using things like money, checks in the mail, whatever helps. Okay. Let's see here. How about this one, number 18, -42 plus -6. We're adding 2 numbers with the same sign. Their absolute values would be 48. The common sign is negative, so -48. Okay. What about problem number 24? -7 plus 12 plus -4. We talked, I believe, briefly yesterday about how addition was commutative. You could change the order in which you add. So in fact, we could do this. And then we could say, let's add those 2 numbers. We're adding 2 numbers with the same sign. So we add their absolute values and attach the common sign. And then we move on, bringing down the next term. Now we're adding 2 numbers with different signs. So we find the difference, the common, or the sign of the number with the highest absolute value was positive. So final answer is +1. Now, I suppose you could write that as a positive one, but we tend not to do that. We just say if there's no sign, it's assumed to be positive. Any questions about that? All right. I want to go back for a little bit here. Let's see here. My apology for jumping around a bit here. I've taught all of this material. I've just never taught it. I've taught it as Math 50, Math 75, and Math 85. And there's bits and pieces from all of that into a single course. So I'm kind of experimenting a little bit in terms of finding things that I want to talk about. Let's see. I guess, you know what? I think we're good. So let's go to page 182. Oops. 1, 2. That's what it is. Okay, it's actually page 170, but it doesn't matter. Doesn't matter. All right, we're going to talk about subtraction of integers. So we've looked at addition of integers, subtraction of integers. There are several ways to go about it, but what we're going to look at is we're going to take subtraction and we're going to change it to an addition problem and then apply the rules of addition. But before we do that, we need to talk about something called, oops, the opposite. Okay. What is an opposite? Well, if two numbers are the same distance from 0 on the number line, but on opposite sides of 0, they are called opposites. Okay, so -5 is the opposite of 5. 5 is the opposite of -5. This operation symbol can be actually 3 different things, maybe perhaps even more, but it could be a negative sign. So for instance, -5. It could be a minus sign, such as 6 minus 5. So there it's a minus sign, or it can be an opposite sign. For instance, let's say I have a variable x that represents some number. If I put this sign in front of it, this is now the opposite of x. So whatever x is, putting this sign in front, it now becomes the opposite. All right, and we'll deal with that as we go along here. Now, let's see here. It says subtraction of integers. To subtract 2 integers, apply the following rule. To subtract 2 integers, add the first integer and the opposite of the second integer. Or in symbolic form, a minus b equals a plus the opposite of b. Or another way of describing it is to say, subtracting a number is like adding its opposite. Okay, let me highlight that for a minute here. Subtracting a number is like adding its opposite. So for instance, let's say we have 7, oops, minus 10. We could change that to 7 plus the opposite of 10. So there's 2 changes that occur. I change the operation from subtraction to addition, and I change the sign of the 10, which is a positive 10, to its opposite, which is a negative 10. So subtracting a number is like adding its opposite. Well, now we can apply the rules of addition that we looked at a little bit ago. Adding 2 numbers with different signs. We're going to take what? The absolute value of 7, the absolute value, whoops, of -10. 10 minus 7 is 3, but the negative was more powerful, so the answer is -3. Now, some of you might be very comfortable just saying 7 minus 10 is -3, and that's great. If you're comfortable doing that time after time, then you don't need to go through all of these extra steps. But some of us will need those to survive there. So we've got some options. All right, so let's take a look at some problems involving subtraction. Any day now, I'll get to it. There we go. All right. So let's say we've got problem number 2. It says 7 minus 13. So that becomes 7 plus negative 13. I've changed subtraction of a number to addition of its opposite. Now, using the rule of addition, I'm adding two numbers with different signs. So I'm going to subtract the larger, or excuse me, the smaller absolute value from the larger, and attach the sign of the number with the largest absolute value. So that's going to be negative. Any questions about that example? Okay, let's take a look at problem number 4. Negative 9 minus 14. All right, now the negative in front of the 9 is not subtraction. That just makes it a negative number. The sign between the 9 and the 14, that is a subtraction sign. So we're going to change subtraction to addition of the opposite. Subtracting 14 is like adding negative 14. Now we're adding two numbers with the same sign. So we add their absolute values and attach the common sign. Another way you could look at this problem is say, you take away 9, you take away 14 more, you've taken away 23. That also works. Any questions on that? Okay, let's take a look at problem number 8, 41 minus 17. Well, here we're subtracting a smaller number from a larger number. So we could go through all of this and et cetera, but 41 minus 17, there's nothing unusual about that. We can just use the subtraction that we always do. Let's see, I've got to borrow and carry. 11 minus 7 is 4. 3 minus 1 is 2. 41 minus 17 is 24. Any questions about that example? Okay, let's see. Let's take a look at number 10. Negative 31 minus negative 30. So I've got negative 31 minus negative 30. I'm going to change subtraction to addition of the opposite. So subtracting the negative 30 becomes adding a positive 30. Okay, so negative 31 minus negative 30 is negative 31 plus positive 30, which I could just write like this. Well, now we're adding two numbers with different signs. So let's see, which one is more powerful? The negative. 31 minus 30 is 1, but it's going to be a negative 1. So way back up here at the start, this is going to be negative 1. Any questions about that? Okay, let's see here. Next up, I want to go to page. Now we're going to look at multiplication of integers. Multiplication and division of integers, the rules are different and I think a little bit easier than the rules of addition and subtraction. Multiplication of integers, it says, when multiplying two integers, apply the following rules. If the signs of the integers are the same, both positive or both negative, then their product is a positive number. So a positive times a positive gives a positive answer. A negative times a negative gives a positive answer. if you're multiplying two, not multing, if you're multing, I'm multing. If you're multiplying two numbers with the same sign, the result is positive. For instance, positive 7 times positive 8 is positive 56. Negative 7 times negative 8 is also positive 56. So multiplying two numbers with the same sign, the result is positive. Now, down here in item 2, it says if the signs of the integers are opposites, one positive and one negative, then their product is a negative number. So positive times negative is negative, and negative times positive is negative. So 7 times negative 8 would be negative 56. Negative 7 times positive 8 would be negative 56. So if you're multiplying two numbers with the same sign, the results are positive. If you're multiplying two numbers with the different signs, the result is negative. Let's take a look at some examples of that. Somewhere down here, here we go. Okay. So problem number 1, 4 times negative 12. Positive times negative would be negative. 4 times 12 is 48. Let's take a look at problem number 3. Negative 7 times negative 17. Negative times negative is positive. Okay. Let's see here. 17 times 7. 7 times 7 is 49. 7 plus 4 is 11. So we get, or just 119. Now, yesterday, when I introduced the idea of x as a variable, I said that we would avoid using that symbol as multiplication. In this particular context, we'll still use it because it shouldn't get confused with being a variable. But if I was going to write it like that, then I would go with parentheses or the dot. Okay. Any questions about that? All right, let's see here. Let's take a look at problem number 6. Negative 3 times 18. Negative times positive is negative. The signs are different, so the result is negative. 18 times 3, 24, carry the 2. So we get negative 54. How about problem 22? Negative h times 2. Well, that would be negative 2h. Or how about problem 20? Negative k times negative 9. Negative times negative is positive, so that's k9. Well, that's a dog of a problem. But we typically put the number, we called it the coefficient of the variable yesterday, we put the number in front. So even though this isn't wrong, this is better. Okay. Any questions? All right. Now, what about a situation where we're multiplying more than just two numbers together? Is it possible to determine the sign of the answer first and then go back and do the multiplication? Absolutely. Let's take a look at 25. A negative times a negative yields a positive. So if we've got a pair of two negative factors, factors are the things you multiply together. If we've got a pair of two negative factors, that's going to produce a positive result. So if we have 2 or 4 or 6 or 8 negative factors, that's an even number, multiples of 2, we would get a positive result. But what if we have an odd number of negative factors? Well, that would give us a negative result. So for instance, here I have negative times negative times negative. Negative times negative, that's two negatives, is positive, times a third negative is going to be negative. So multiplying an odd number of negative factors, we get a negative result. Well, now what do? I go back and I predetermined the sign. I can say, well, 2 times 7 is 14, times 3 is 42. So my answer is going to be negative 42. Any questions about that one? Okay, let's take a look at problem number 30. Negative 2 times 3 times 6 times negative 4. There's 4 factors. There's 2 negative factors. That's an even number. So my answer is going to be positive. 2 times 3 is 6, times 6 is 36, times 4, 24, carry the 2, 144. And so 144. And I just put the plus sign there, positive sign, because I predetermined that it was positive. All right. How about, let's see, let's take a look at number 32. That says 5 times negative 6 times negative 4 times negative 1. There are 4 factors, but there are 3 negative factors. That's an odd number of negative factors. So the answer is going to be negative. And then I can go back and just calculate without dealing with the signs. So our final answer, negative 120. Okay. Any questions about that before we go on? All right. So let's now go to division. Let's see here. Oh, where did I go? I missed it there somehow, went right past it. There we go. Nope, nope. That's not what I wanted either. Sorry about that. Here we go. That's what I wanted. Okay. Division of integers. When dividing 2 integers, apply the following rules. If the signs of the integers are the same, both positive or both negative, then their quotient is a positive number. A quotient, that's the result of division. The answer is the quotient. Oh, so a positive divided by a positive is a positive, and a negative divided by a negative is a positive. If the signs of the integers are the same, both positive or both negative, then their quotient is a positive number. So positive 8 divided by positive 2 is positive 4. Negative 8 divided by negative 2 is still positive 4. Okay. Then it says if the signs of the integers are opposites, one positive and one negative, then their quotient is a negative number. So positive divided by negative is negative, and negative divided by positive is also negative. So 10 divided by negative 5 is negative 2. Negative 10 divided by 5 is also negative 2. So when you're dividing 2 integers, if the signs are the same, the results are positive. If the signs are different, the results are negative. That sounds awfully familiar. That's the exact same rules for multiplying integers. So in fact, we can lump it all together and we can say it this way. When you are multiplying or dividing 2 integers, if the signs are the same, the result is positive. If the signs are different, the result is negative. Okay, so multiplication, division, sign numbers, same set of rules. That's nicer than the addition and subtraction rules. All right, let's do this. What I want to do first of all is I'm going to look at these problems here and determine would the result be positive or negative. So positive times negative would be negative. Number 3. Negative times negative would be positive. Number 7. Positive times positive would still be positive. Number 14. Positive times positive is positive. How about number 15? What about 0? Does 0 have a sign? Well, 0 is kind of neutral. It's neither positive nor negative. So what would 0 times a negative number be? Well, 0 times anything is 0. So the answer wouldn't be positive or negative. It would just be
The
0.
same, negative?
Just be 0. Because 0 is not positive or negative. You could write -0 and then I'd come along and I'd cross out that negative sign and say, it's just 0. Okay. All right, let's go back here. Let's look at division. 8 divided by -2. Would the answer be positive or negative? It would be negative. Okay. How about number 61? Negative divided by negative, the answer would be
Positive.
positive. How about 65? How about I try to quit trying to highlight it? Positive divided by negative would be
Negative.
68. Negative divided by negative would be?
Positive.
Let's take a look at 71. Here we're dividing by 0. Have you ever heard the expression, it's all fun and games until somebody loses an eye? Well, there's a t-shirt that says it's all fun and games until somebody divides by 0. And we say that dividing by 0 is undefined. So -16 divided by 0 is not negative, it's not positive, it's not 0, it's undefined. 0 divided by -16 would just be 0. But -16 divided by 0 would be undefined. We can't divide by 0. It's a big no-no. All right. What I want to talk about now is taking a base and raising it to a power. And let me explain. Let's say we have 2 to the 3rd power. 2 is the base and 3 is the power or the exponent. Okay. So 2 to the 3rd power, or 2 cubed, we say cubed because a cube has 3 dimensions like a Rubik's Cube. So this says we have 3 factors of 2, or 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. So 2 cubed is 8. 2 is the base, 3 is the exponent or the power. All right. Any questions about that example? What if we have 3 to the 2nd power, or 3 squared? That's 2 factors of 3 multiplied, which is 9. 3 is the base and 2 is the exponent. What about this case though? What if we have -3, the quantity squared? When there's an exponent attached to a set of parentheses like it is here, that says that that whole thing inside the parentheses is the base. So we have -3 times -3. We have 2 factors of -3. In which case, negative times negative is positive, so we get a +9. Any questions about that example? But now let's take a look at this. Let me rewrite that a little better here. Okay, not much, but a little. Here, the negative sign is not captured inside the parentheses. So the base is actually just the 3. So this is 3 times 3, because there's 2 factors of it, with a negative sign attached out front. Well, -3 times +3 is -9. Think of it this way. If I said 4 squared minus 3 squared, 4 squared, what's 4 times 4? That's 16. 3 squared, that's 3 times 3 is 9. So this would be 16 minus 9, right? But let's just get rid of the 4 squared. So it's basically -9 or -9. Okay, let's look at a few more examples of this. Let's say I've got 5 the quantity squared. That is 5 times 5 with a negative sign in front, negative 25. But if I've got negative 5 the quantity squared, that is negative 5 times negative 5, which is positive 25. Now, when the exponent is even, it affects the sign of the answer, as you can see. But let's take a look at a different case. Let's take negative 2 cubed and negative 2 cubed. The first example, this is 2 times 2 times 2 with a negative sign in front, which is negative 8. The second example is negative 2 times negative 2 times negative 2, which is also negative 8. So we get the same answer, but the process of getting there is quite different. On the first one, the base is just the 2. On the second one, it's the negative 2. All right. We've looked at a lot of information today. We've looked at addition, subtraction, multiplication, division, and dealing with powers, exponential expressions with integers. Also, 0 divided by a non-zero number is 0, and a number divided by 0 is undefined. So that's a lot to look at. Fortunately, you've got all weekend to take a look at it, right? Which hopefully that doesn't mean that, Sunday night at 11:30, you'll decide, oh, I guess it's time to do my homework that's due Monday. Why not get it done early and then have the weekend to goof off? You betcha. All right, I'm going to stop the recording. Give me just a minute here.